Okay, so moving on to section 5.4. Today we're going to use the sum and difference formulas for sine, cosine, and tangent. Now notice there are 6 of these formulas here. And, if you took Math 3 last year, right, this was in Chapter 9, and so some of this might be familiar and might be reviewed for some of you. So under normal circumstances, right, I would probably derive all these equations for you just so you know that these formulas don't just come out of thin air. But, for the purpose of time and, the circumstances that we're under, right, everything's being condensed due to the distance learning. I'm just going to have these formulas here, and then we're just going to refer to it. Okay, so these formulas do come from someplace, and you can probably look up videos on how to derive it if you really wanted to. It's actually on page 400 in your textbook. But like I said, I don't have time to explain that to you here. Okay. All right, so let's take a look at the first example here. It says find the exact value of the expression sine of 195 degrees. And you are asked to do this without a calculator. Okay, so even though it doesn't say that, it's implied. And you want to find the exact value. So your calculator is not going to give you a radical answer. And if you look at sine of 195, right, that number 195 is not on your unit circle. And so you want to write it as a sum, or you can write it as a difference using values on the unit circle. Okay, so that means you really have to know your unit circle. So one way I can do this is saying the sine of 195 is the same thing as the sine of 135 plus 60 degrees, right? And these two numbers, right, if you memorize your unit circle, which you should have, are on your unit circle. And if they're on your unit circle, right, you can now use the sine sum formula, apply it, and then evaluate. Okay, so let's evaluate. So it's basically going to be the sine of the first angle, which is 135, times the cosine of the second angle, cosine is 60, right? And then plus cosine of the first angle times the sine of the second angle, sine of 60. Okay, so once you have the formula all written down, you can evaluate. Okay, so the sine of 135 degrees in quadrant number 2 is positive root 2 over 2. The cosine of 60 is 1/2. Cosine of 135, because you're in quadrant 2, it's negative root 2 over 2. And the sine of 60, right, is just root 3 over 2. Okay, so if you simplify over here, you're going to get root 2 times, root 2 times 1, which is root 2. This is going to be negative root 6 all over 4. Okay, now an alternative way of doing this problem, right, instead of using the sine sum formula, you could have done a way too. You could have said sine of 225 minus 30 degrees, right? In which case, you would have to use your sine difference formula, okay? So if you use equation number 2 to evaluate this and expand, you should get the exact same answer, okay? All right, so let's move on to problem number 3, the cosine of pi over 12. Again, pi over 12 is not a value on your unit circle. You want to split it or rewrite pi over 12 such that these values are on your unit circle. So I'm going to use the cosine of pi over 3 minus pi over 4. And if you ask yourself, hey, does pi over 3 minus pi over 4 give you pi over 12? This would be 4 pi over 12. If you multiply this guy by 3 over 3, this will give you 3 pi over 12. In fact, 4 pi minus 3 pi over 12 will give you pi over 12. Okay, so this is correct. This will give you this. And then, of course, you would use your cosine difference formula, which is stated here in equation number 4, right? Which basically states that I take the cosine of the first two angles, cosine of pi over 3, cosine of pi over 4, right? And then add the sine of the first and the sine of the second. So add the sine of the first and the sine of the second. Okay, and the very last step is for you just to evaluate these values here. So let's do that, right? Cosine of pi over 3, or cosine of 60 degrees, right, is 1/2. Cosine of pi over 4, root 2 over 2. Sine of pi over 3, right? That's going to be root 3 over 2. And then sine of pi over 4 is root 2 over 2. Okay, so if you simplify over here, you're going to get root 2 plus root 6 all over 4. And that would be your exact answer for cosine of pi over 12. Okay, let's do this last problem on this first page. Let's do a tangent one. The tangent 11 pi over 12. So this one's a little bit trickier in the sense that, 11 pi over 12, you're going to have to play around with some of the radian values that that are on your unit circle. And if you play around with it, right, you should get this tangent of 7 pi over 6 minus pi over 4. Right, let's double check, right? This would be 14 pi over 12 minus 3 pi over 12, right? 14 minus 11 will give you, 14 minus 3 will give you 11 pi over 12. So, it might take you a little bit of time to kind of play around with the radian values such that you get this number or this argument. But once you have it, right, then you could use a tangent difference formula. And let's go back and look at our tangent difference formula right here. It's in equation number 6. It says take the tan of the first angle minus tan of the second angle divided by 1 plus the tan of the first angle and tan of the second angle. Okay, so let's do that. We're going to take the tangent of the first angle and we're going to subtract the tangent of the second angle all over 1 plus tangent of the first angle times tangent of the second angle. Okay, so once you have the angles and everything, right, written out and you have the formula, the rest is, I always like to say in class, right, the rest is all algebra. And so let's practice and evaluate. So the tangent of 7 pi over 6, well, what's the tangent of pi over 6? In the first quadrant, right, it's the ratio of y over x. And so the y value is 1/2, root 3 over 2. The tangent of pi over 6, right, is 1 over root 3, which is root 3 over 3. That's the tangent of pi over 6, right? But I want the tangent of 7 pi over 6. 7 pi over 6 is in quadrant number 3. And so the tangent, the ratio of y to x in quadrant 3, is still going to be positive, right? Negative y over negative x is still positive. So likewise, the tangent of 7 pi over 6 is just root 3 over 3. Okay, so a little bit of unit circle stuff. So we're going to get root 3 over 3. Tangent of pi over 4, right? You should have that memorized. Root 2 over 2 divided by root 2 over 2 is just 1. Tangent of 7 pi over 6, again, we evaluated that. That's root 3 over 3. And then tangent of pi over 4, again, is just 1. Okay, so now you have this complex fraction with radicals, right? The way you simplify, right, is to multiply top and bottom by the LCD of 3, 1, 3, and 1. Okay, so the least common denominator of all 4 denominators, you're going to get root 3 minus 1. Over here, if you distribute, you're going to get 3 plus root 3. In fact, I'm just going to write the root 3 over here, okay? So normally you would write 3 times 1, which is 3, 3 times root 3 over 3, which is root 3, but I just switched the order. And this will not be the final answer, right? You know you can't have radicals in the denominator, and you have to multiply by the conjugate. So lots of algebra when you're doing a tangent type problem. And, oh, I'm sorry, I made a mistake here, right? 3 times root 3 over 3 is root 3. 3 times 1 is 3 over here. There should be a 3. Okay, so in our numerator, right, this is root 3 minus 3 quantity squared. In our denominator, right, remember this is the pattern of difference of two squares. A plus b times a minus b is root 3 squared minus 3 squared. Okay, difference of two squares here. This is the square of a binomial, okay? All right, so practice foiling. Let's do this in our head. Root 3 squared is 3. Minus 2 times a times b. 2 times this is 6. Times this is minus 6 root 3. And then you square the last term, which will give you 9. Root 3 squared is just 3. 3 squared is 9. And then let's continue to simplify. Over here, you're going to get 12 minus 6 root 3 over negative 6. Okay, you no longer have a radical in the denominator, but remember, you have to completely simplify. Okay, so factor out a 6 between these two terms. These 6's will cancel out, and this will be your final answer. Okay, you could distribute the negative, in which case you'll get negative 2 plus square root of 3. Either one of these answers is acceptable. Okay, so if I go back to the original problem, right? The only trick part is rewriting this in terms of values on the unit circle. And of course, you have the formula in front of you, right? Plugging it into the formula. The majority of this problem, right, is practicing algebra skills, right? Simplifying complex fractions, simplifying radicals, the square of a binomial. Okay, some of you still might be struggling with this. You might say, oh, that's just 3 minus 9. Okay, it's not 3 minus 9, right? This is a minus b quantity squared. In case, just for reference, a minus b quantity squared is a squared minus 2ab plus b squared. And then what the heck did you do over here, Mrs. Zhu? This is a plus b times a minus b, right? A plus b times a minus b, is a squared minus b squared. Okay, so oftentimes students have no trouble with the new content. It's always the old content that they struggle with. It's the algebra skills. And if you want to move on to calculus, right, your algebra skills need to be really, really strong.